LangGraph's tool-based agent coordination leverages annotated function decorators and state injection to enable dynamic handoffs between specialized agents. The frameworks command, class, and injected state annotation work together to create context-aware transitions while maintaining message continuity across agent boundaries. We're about to examine how a custom handoff tool gets constructed, where the decorator pattern combines with state injection to create a reusable component that can transfer control between agents while preserving conversation history and task context. The implementation will show how tool arguments get annotated for automatic state population and how the resulting command updates the parent graph's execution flow. From typing, import annotated. From LangChain, tools import tool, base tool, injected tool called. From LangChain, messages import tool message. From LangGraph, types import command. From LangGraph, prebuilt import injected state. Def create custom handoff tool asterisk agent name. SDR name, SDR none description, SDR none base tool. At tool name, description equals description. Def handoff to agent. Hash you can add additional tool call arguments for the LLM to populate. Hash, for example, you can ask the LLM to populate a task description for the next agent. Task description, annotated SDR, detailed description of what the next agent should do, including all of the relevant context. Hash you can inject the state of the agent that is calling the tool. State, annotated dict, injected state. Tool call id, annotated SDR, injected tool call id. Tool message equals tool message. Content equals F, successfully transferred to agent name. Name equals name. Tool call ID equals tool call ID. Hash you can use a different messages state key here if your agent uses a different schema. Hash e.g. Alice messages instead of messages. Messages equals state messages. Return command. Goto equals agent name. Graph equals command, parent. Hash note. This is a state update that will be applied to the swarm multi-agent graph, i.e., the parent graph. Update equals messages, messages plus tool message. Active agent, agent name. Hash optionally pass the task description to the next agent. Task description, task description. Return handoff to agent. This code demonstrates a custom handoff tool factory for LangGraph agents, enabling context-aware agent transitions. The Create Custom Handoff Tool function generates a tool that allows one agent to transfer control to another while passing along contextual information and state updates. The implementation uses LangChains at tool decorator to create a callable tool that accepts a task description parameter for the LLM to populate, along with injected state and tool call ID. When invoked, it constructs a tool message confirming the handoff and returns a command that directs the graph execution to the target agent while updating the parent graph state. The state update includes the accumulated messages, the new active agent, and optionally the task description for the next agent. This pattern is particularly useful in multi-agent systems where agents need to specialize in different tasks, but maintain continuity of conversation. By injecting the current state and allowing the LLM to generate a task description, the handoff becomes more context-aware than simple routing. The trade-off is increased complexity in managing state updates across agents, but this is necessary for maintaining coherent multi-agent interactions. The use of injected state and command from LangGraph's types module ensures proper integration with the framework's execution model. Let's break it down. From typing, import annotated. Imports annotated from the typing module, which enables adding metadata to type hints while preserving the original type for static type checkers. From LangChain, tools import tool, base tool, injected tool called. imports the tool decorator, base tool class, and injected toolCallId class from LangChain's tools module. These provide the foundation for creating custom tools with the @tool decorator, defining base tool functionality, and handling injected tool call IDs in the LangGraph context. From LangChain, messages import tool message. Imports the tool message class from LangChain's messages module, which provides a message type specifically for tool-related communications in agent workflows. From LangGraph, types import command. Imports the command class from the LangGraph types module, which represents one or more commands to control graph execution flow and state. From LangGraph, prebuilt import InjectedState. Imports the InjectedState class from LangGraph's prebuilt module, which provides annotation functionality for injecting graph state into tool arguments. Def create custom handoff tool asterisk agent name, SDR name, SDR none description, SDR none base tool. Defines a function, create custom handoff tool, that takes 3 keyword-only arguments: agent name, required string, name, optional string or none, and description, optional string or none. The function returns an instance of base tool, indicating it creates a custom tool for agent handoff operations with configurable metadata. @toolName, description equals description. Decorates a function as a LangGraph tool with the specified name and description. The @tool decorator registers the function as a callable tool in the graph, making it available for execution with the given metadata. The name parameter identifies the tool, while description provides contextual information about its purpose. Def handoff to agent. Defines a function named handoff to agent that begins a function definition block. The function appears to be part of a LangGraph implementation, likely designed to transfer control or execution context to an agent within the graph-based workflow system. The opening parenthesis suggests parameters will follow, though none are visible in this segment. Task description, annotated SDR, detailed description of what the next agent should do, including all of the relevant context. Defines a typed variable, task description, as a string with an annotation describing its purpose, to provide a detailed explanation of what the next agent should do, including all relevant context. The annotated type hint indicates this is a strongly typed field with metadata, where the string value should contain comprehensive instructions for subsequent processing steps. You can inject the state of the agent that is calling the tool. State, annotated dict, injected state. Declares a parameter named state that is type annotated as a dictionary and marked with the injected state annotation. This indicates the parameter will receive the current state of the agent calling the tool, allowing the tool to access and potentially modify the agent's state during execution. The annotated wrapper provides metadata about the parameter's intended use without affecting runtime behavior. Tool call id, annotated SDR injected tool callId. Declares a function parameter named tool callId with type annotation SDR that is automatically injected with a tool call identifier from the graph state. The injected tool callId annotation indicates this value comes from the execution context rather than being passed explicitly by the caller. Tool message equals tool message. Content equals F, successfully transferred to agent name. Name equals name. Creates a tool message object with a success message indicating a transfer to the specified agent name using the provided name parameter. The message content is dynamically generated using an F string to include the agent name,
and the name parameter is passed directly to the constructor. This appears to be constructing a status message for tool execution feedback.
Tool call ID equals tool call ID.
Assigns the value of the tool called variable to a parameter or attribute named tool called. This appears to be passing a tool call identifier to a function or method, likely for tracking or referencing a specific tool invocation in the LangGraph framework.
Messages equals state messages.
Extracts the value associated with the key messages from the state dictionary and assigns it to a variable named messages. This retrieves the message history or conversation context stored in the current graph state for further processing.
Return command.
Returns a command object that represents one or more instructions to control graph execution flow and state management. The command class is specifically designed to encapsulate directives that influence how the LangGraph processes tasks, manages state transitions, or coordinates between nodes. This line indicates the function or method is producing a control structure rather than raw data or simple values.
Goto equals agent name.
Sets the goto parameter to the value of agent name, indicating that execution flow should be redirected to the node or agent identified by agent name in the LangGraph workflow. This is a control flow directive that determines the next step in the graph's execution path.
Graph equals command, parent.
Assigns the value command, parent to the variable graph. This sets graph to a command that references the parent node in a LangGraph execution flow, typically used to control graph traversal or state management.
Update equals messages, messages plus tool message.
Updates the state by appending a new tool message to the existing messages list. The update dictionary specifies that the messages field should be replaced with the concatenation of the current messages array and a new tool message, effectively adding the tool's response to the conversation history.
Active agent, agent name.
Assigns the value of agent name to a key active agent in what appears to be a dictionary or object literal. This establishes or updates the active agent identifier in the current state or configuration.
Hash optionally pass the task description to the next agent. Task description, task description.
Passes the task description variable as a key value pair in a dictionary, making the task description optionally available to the next agent in the workflow. The value of task description is preserved and forwarded, allowing subsequent agents to access the original task context if needed.
Return handoff to agent.
Returns the value of the handoff to agent variable, which appears to be a Boolean or similar control flag, indicating whether execution should be transferred to another agent in the LangGraph workflow. The handoff tool factory demonstrates LangGraph's decorator-driven state injection pattern, where @tool combines with InjectedState annotations to create context-aware transitions between specialized agents. The Create Custom Handoff Tool function generates a reusable component that preserves conversation history through state injection while enabling dynamic control flow via the command class. By annotating parameters like state and tool called, the framework automatically populates these values during execution, allowing the tool to access current context and maintain message continuity. The returned command object then updates the parent graph's state with the accumulated messages, new active agent, and optional task description, all while redirecting execution flow to the target agent. This pattern balances flexibility with complexity, as the state management overhead enables coherent multi-agent interactions that would otherwise require manual context passing between isolated components. The key insight is how the decorator pattern and state injection work together to create reusable, context-aware handoffs that maintain both conversation history and task context across agent boundaries.
The tool injects a state into the decorator, yet the decorator injects the tool. Who injects the injector when both are injected?